All right, 1 December the 3rd. All right, I got another easy one today, so it'll be fast. But I tried to think about this last night, but I fell asleep immediately, so I still don't know how to resolve this. So we're gonna read the hints and see if we are missing anything. But let's get this one done first. Okay, you're given a string representing a large integer. An integer is good if it meets the following conditions. It is a substring of num with length 3. You're given a num representing a large integer. An integer is good if it meets the following. It is a substring of num. Okay, it's 3. It consists only of one unique digit. Return the maximum good integers as a string with an empty string if no such exist. There may be leading zeros in num or a good integer. Okay, so basically we need to find triplets, right? Triplets with the same. Okay, triplets. So we get a triplets. We get a triplets. Okay, what if we have 4 that's exactly the same? Good call. Like, what if we have just put another 7? What is it gonna be? Oh, so we return 1. I thought I return the maximum. Oh, that's fine. So we just go through everything, find the biggest, find the biggest. So we scan, blah blah blah. We find 3. We go and we go for it. No. We scan. We scan the sliding window. So we just check if how are we gonna sliding window? So we get 3, right? And then we check if they're all the same, and then keep going on. I mean, it's 3. Let's not think about 3. Let's think about if it's n. How would you check that? Well, we just, count. If we have 3 the same, then we submit, right? And then we'll get a new one. Yeah, if we get 3, we submit. And then we get the next one. If it's still the same, it doesn't matter, right? It doesn't matter if it's a new one. If it's 3, we submit. If it's not 3, if it's the same, then we just keep counting. It doesn't really matter. We just keep counting. If it's different, then yeah, okay. That sounds like a plan. Oh. All right, so what we're gonna do is we're gonna have a string. Oh, how does interesting array string comparison? How do we do that? So equals there's no large or small. Huh. Well, I guess it's fine because they're all the same, so we can compare the first one. But I still wonder. one string larger than the other. Can we do that? Ooh, compared to. Okay, not compared to. Okay, rest. This is definitely the smallest, right? In fact, let's J shell this. Just no. And say A is equal to this. B is equal to, I don't know, 1. A dot compared to B. Yeah, that it is the smallest. Good. And then what we do is substring. How do we get substring? Java get substring. Start and exclusive. Okay. Count. Int count is 0. Int I 0 I smaller num dot length plus. Actually no. We shall do 1. Right? And now we say if num dot char at I is equal to num dot char at I minus 1. If that, then count plus plus. Right. If that, count plus plus. And then we can check. Yeah, if it's not equal to, I just reset to 0. I don't really care because I already handled it. Right? We're gonna say if count is equal to 3. Yeah, just do the first one. That's fine. Oh, can we say math.maximum? I don't really think so. String temp num dot substring I minus 1 minus 2, right? Minus 2 and I plus 1. That's the substring. So if temp dot compared to res is larger than 0, res will equal to temp, and else count reset to 0, and at the end we return res. Oh, that's interesting. Out print line. Just try to check if we did get all the ones out. Wait, hold a second. The 777 is not getting it. How? So we start. This is not equal to. Oh, shoot. Because you check this is equal, Then we plus 1, plus 1. It's not equal to 3, it's equal to 2. Because you set count, I actually set count equal to 1. Yeah, just set count equal to 1. Count is not starting with 0. Count starting with 1. I mean, there's nothing really special about this. How would you do in Python? I forgot how you should do this in Python. Oh, that must be a contest. I probably do, I don't know, I probably count it group by. Yeah. Java is more verbose for sure. Oh, what? Contains. Oh, it's do this. Let's do two comparisons. The max digit. Oh, new string can do this. Okay, interesting. All right, so that's that. Oh, take a look at the hint. DP, bit manipulation, bit mask. I did do bit manipulation and bit mask. DP with bit mask. I was using DP with bit mask, but I guess it's not. I guess it's a different type of bit mask. Maybe. Yeah, I think the graph is correct, right? We did create a graph. And once we create the graph, yeah, the question is just basically this, right? We have a graph. We have a graph, we know who connects to whom. And then we need to figure out how many different ways to do this. Scene is bit manipulation, but this is 3-level DP. I think that's the issue. Can we reduce it to 2-level DP? The length is not necessary because scene, the number of, oh yeah, why you use the length? Scene already contains information. You're duplicating the information. So what we're saying is we don't use, I think, hold on. So we go 2 levels, okay? You know what? Let's do this inside here. So what we need to do, graph is fine. This is fine. So we'll delete this. No length. It's just I'm at index and scene is what have been created. So at this point, right? hold on a second. So we start scene as 0, right? And then index, right? Coming in. So we say previous scene is this much, right? These are seen. And now we're going to give the current one. And if it's already been used, that's a 0, right? And if it's equal to no, it's after we set the scene, right? And then if it's all filled, that's 1. And if it's not, and because we can put them in different order, we put them in different order. Yeah, because we start with different things, so we put them in different order. Therefore, this is not necessary. And of course, this is, we're gonna deal with this. And we still say index if it's not null, then we can do return this. Right, so the previous is this, and now we're gonna do the current index, and then we already find out how many. And then we do this, right? And we say if scene is equal to, we need the end filled, int filled. We're gonna do filled at here. Okay, so this dot not filled shall equal to 1 left shift n, right? Minus 1 filled. And we say, oh no, if it's equal to filled, right? Now we return 1. Otherwise, this will be this, and we don't need this, sure. And we do this, and we do this. Okay, graph is fine. Oh, all of these are not necessary. I was just trying yesterday. Special case is ridiculous. Right. I do this. We'll start with this. Run it. It's all right. 12. Looks right. Still not correct. It still times out on this one. But if I don't do this one, I think the rest should be right. Right? The rest is right, but how? 14, right? 1 left shift 14. 2 to the 14 times 14. 229,000. I don't understand. Different things put at the front. I with 0. maybe we can do a check beforehand, so we reduce the number of function calls. I don't think so though. I don't think. I'm just playing around. It just feels like extending too much, right? It's extending too much. It tries to go through. Maybe we need to do bottom up. Okay, maybe we do bottom up. Don't do top down. I think top down is giving us trouble. Let's try bottom up. It's the recursion. I feel like it's we are rehitting a lot of the things maybe we can do, you know, instead of doing so how is bottom up going? We'll have, in this case, right, it'll be 1 2 3. That's actually do a simpler one, right? 1 2 4 8 16. How about this? 1 2 4 8 16. I'm just trying to see how we can do a bottom up. Shouldn't be too hard. 1 2 3 4 5. It's 32, right? We have 32. Oh, 32 is still too much. 1 2 3 4 16. Let's do 6. Let's not do this. Let's do this. Okay. So 1 2 3 4. 2 1 left shift 4. 2 to the 4 16. So I have 16. So we have 1 2 3 and 4. I have 16. 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Okay. Right, 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Oh shoot, we need one more for 16. Actually no, we don't need. 15 is good enough. Right, so I have 1 2 3. All right, so we say 0 will connect to 1 2 3, right? 1 has 0 2 3. 2 has 0 1 3, and 3 has 0 1 2. Okay, so we start calling 0 0, right? 0 0. Okay, so we start call 0 0, and then to call 0 0, and then I say no, I mean, we want to fill this up. So maybe we should first detect is oh, but it's it's different, right? It's different. So basically, let's say 1 2 3 4, right? This is 15, and then if this is a 0, this one's not filled, right? Or this one's not filled, or this one's not filled, or this one's not filled, right? If this one's not filled, so this is what? It's 3, and this is 14. So 3 14 should be 1, right? 3 14 is 1. And the answer is the sum of the first column, right? So 3 14 is 1, and this is a 13, right? So 2 13. 2 13 is 1. And I can say 1 Well, actually, no. Shift. We're doing shift. That's not right. That's not right. This is 0. Right, so this is 14. This is 1. 0. This is shift 1. Right, so shift 1. So it's 1. It's 13. And wait, hold a second. 15 minus 1, 15 minus 2 is 13. Yeah. Is this is what's this? 8 plus 3. This is 11. This is 11. So 2, 11. And this is 7. 3, 7. 3, 7. Oh, there's no rule to start. But I mean, we can iterate in this, right? And then that's basically 1. And then what? And then I say, yeah, if everybody else is filled, now we say if 2 is not filled, I still don't understand. Why was this? Oh, because it explodes too much, right? It explodes too much. I think it's the DP issue. Should be we're already seeing this much. And with the remaining, how many different ways we have? Because if you do bottom up, it's really hard. Like we have this and then what? Now this is the last one, right? Last one. This is the last one. This is the last digit. And then we can also do second to the last. Right? Second to the last. So based on what your last digit is, the second to the last can have different. Yeah, then we'll still grow. I don't think that's the right way. I'm thinking maybe we can do, maybe it would be just like DP scene. I want to call it DP state, right? Like given the current state, what is the total? So what we want to call is DP0, right? This is what we want. Given this, give me all different ways. Okay. So I say, at the first spot, I have 4 different ways. Okay, I have 0, 1, 2, 3. Okay, if it's a 0, then I do DP. You take a 0. So we do 0, 0, 0, 1. If I do this, that's going to be DP 0, 0, 1, 0. DP 0, 1, 0, 0, and then DP 1, 0, 0, 0, right? So we do 4 different ways. And for the next, you also do, like if you do this, if you take 0 as the first, then you do its neighbors, right? What neighbors it has. So we have all those, and we have all those. I don't know, does that make sense? So we kind of reduce it to You still have to, for each one, you will go out to 14, right? Each one go out to 14. Each one go out to 14. I think that's the problem. At the first level, you have 14 long, right? You say, okay, I do this, and then it will go out. The second one will go out as well. Yeah, I have to be gentle. I'll put a request. It's not my fault. I never say it's your fault. Of course it's not your fault. It's the toilet's fault. Come on, come on. Let's go. Ugh. But we still have to go through all the... Yeah, that's the issue. I mean, we compute all of them, but we still have to go through. Unless we can reduce the number. Yeah, maybe we just reduce the number of calls. Yeah, let's try. So let's go. Oh, we change the memo as well. So memo will now be 1. Okay. So DP is just gonna be the let's call it state. Okay, so we're gonna call it state. All right. And we give it the state, right? And then each time we call it just the next one, and we have whatever we need to do. Then we go through all the index, whichever I can go. No, not whichever I can go. Yeah, whichever I can go, right? Because give me the state is current step. So giving me this state, right? How many different ways I can do? So I go through this, right? I go through this, and then yeah, because each one, hold a second, each one. So we start with state of 0. So we go through everyone and see, which one we can go. And we go. And then we have this one done. But what are the next step? Right? It is, you need the next step. Right? You need the next step. So maybe it is index. So we say this, we do this index, right? And we set the state. And then it has that much. Maybe it's maybe we still need the index, but we only need the state for. Is that true? That's actually not true, because you can have the same state. We use these 3, right? We use these 3. So the state is the same, but they can be of different orientations, right? They can be different permutations. That's why we do. I don't know. What is another hint? Okay, that's exactly what I did. I mean, it's not the last in the, I would just, is a current to use. But I time out. Okay, so maybe, yeah, the other idea is not right. Hold on, it's okay. Let's it's okay. Let's do this, and then don't make the call. Okay, don't make the call. Let's reduce this. Okay, don't make the call here. Okay, we will check here. Okay, we check here. We make sure that that call is not made. So what we're gonna do is if, right? If one left shift neighbor, right? One left shift neighbor. One left shift neighbor and scene is equal to 0, right? That means we haven't used it yet. Then we will do it. We'll make the call. Right, if this one has not been used yet, we'll make the call. Otherwise we don't. What do you think? Well, I think it'll still be right. Line 1. Oh. Oh, I think it's just, I forgot a class. I think it's still right. Yeah, we just don't do as much. Hold on, let's take these to here. See, is it working? We're reducing the number of function calls, but yeah, I don't think so. It's still I don't know. I have no clue. We need a way to because I need to reduce, right? I need to reduce the number of calls when everybody else has been called, because right now the graph just get everybody. So what if your graph is a set? Okay, your graph is a set, and we pass in another thing. We don't need to pass in another thing. We pass in, we just check the scene. Well, if you check scene, that's still gonna go 14 times. We will have another set, which is the remaining available, right? Remaining available. And if that is the remaining available, and each time you're just gonna remove whatever is available, then you will, oof, Lordy, you have to add it back. So what you're saying, we have this much available, right? And then we go through the available, and then we do the first available. I don't know, we're looking at the index at the moment, right? An index has bunch of connections, right? Go out. We don't want to go through all the connections. We only want to go through the remaining available points. And I have the remaining available. Okay. Then we check the first one, see if it's in it. If it's in it, I will remove it and pass it down. Okay. And once we're done, we put it back. The second one, I'll remove it. Oh, okay. This my work. This my work. So I'll need to change the graph. This is gonna be a set. Okay, which means this is a new hash set. Okay, this is the same. Memo is the same. This we have to add a new one, available. Right, available. It's okay. We can just say set integer, right? Available. Maybe you can use global for this. Yeah, I think I can use global for this. I don't have to pass. I can use this for a global. So I say, oosh. Right. Available equal to new hash set. And then what I do is I do this. Available.add I as well. Okay, so these are total available, right? So every time we do this, we don't go through this, we go through the available. So we need to turn the available into because I want to iterate through available. So I can remove, I can add, right? Can I make changes as I iterate through? Iterate through set and change set. I don't know if that makes sense. Iterator, we can do an iterator. Set the iterator. Well done. Next, we get the element. We can remove it, but I also want to put it back. That's the thing. Maybe we should make a copy. Can we go to say a set? Let's say turn. How about this? Java set to array. Can we do that? To array. I can say temp. Okay, we can say integer temp equal to available dot to array. Oh, this sounds all right. No, how do I do this? Oh, I have to go. So it's a variable dot to array new integer this available dot size. Okay, and then where we're gonna go is for int a of the temp, right? Then we say if graph.getIndex.contains a and something one left shift a and scene equal to 0. If both, then we will do this. And there's no neighbor. This is A. Okay, what happened here? New integer 0. Okay, so we will say if go through all the variables, right? And the available if it's inside the graph, and if it has not been seen before, then we can use this for the next one. So I do that. But actually, before I do that, there's another thing we must do, which is we have to backtrack this thing. We have to say available, right? Available.remove a, okay, and then we do this, and then available.add a. So we need to backtrack. Then we'll go to the next one, right? I'm going to try the next one. Okay, I'm not sure. Do you think this one gonna work? No. No clue, man. No clue. Alright, just give this a shot. Does this work? No. I don't think so. Still doesn't work. Still too much. What the hell? The copy takes time. How fast is this one? Actually, so I want to know. It's this timeout, right? Yeah, it does. Okay. Which part? I can hit all the way to 515, 512. No, cannot enter 512. Okay, so I think there's maybe some symmetry thing I didn't realize. You know, some symmetry. Yeah, let's go back to the basics, right? 2, 2, 3, 6. Okay. So 0 have 0 and 2. 1 has nothing. 2 has 0, right? So if we go 0 first, then the next one has to be a 2, right? 0 first, next has to be a 2. Oh, wait, 1 is also 2. So 0 is 2, 1 is 2. 2 has 0 and 1, right? So 0 goes to 2. So 2, we have 0 and a 1. And we cannot pick 0, so we pick 1. Right, so that's one way. Can we leverage symmetry for this? So we have 0, 2, 1. And then well, definitely we have one symmetry is we can always go reverse. Right? We can go reverse. So if I find everything that starts with 0, we can always go 1, 2, 0. Right? And we can always go back. So if I find from 0 to some value, okay, we have, however many from 0 to the end. We have however many. And all of those can double. Like they all end, but it's like ending at starting with 0, right? End at this. It can always go reverse. It can always go reverse. But all the reverse will be ending at 0. It's just starts from something and you will end at something. Okay? Hold a second. I say we start from 0, we have all those different ways, right? And then we say, okay, now we're going to start with 1. But if we start with 1, all the zeros are already done, right? But there might be other ways that does not end in 0. See, that's the thing. There are other ways that may not end in 0. If we start at a 1, there may be ways that does not end in 0. I don't know. I just want to, let me submit again and see. How many? Is it the same? 587 or 529? No idea. It's alright. I think I am going to... Alright, I'll give it one more shot. Alright, I'll probably think about it again tonight. But if I don't have any intuition, I'm gonna have to see other people's result. I don't know. It's just... It doesn't work. Right? This one doesn't work. The other one doesn't work. None of them works. But I do feel like I am repeating myself. I can see that. I am repeating myself. But I just don't understand how I can make it better. I don't know. Alright, I'll see you guys tomorrow.